This video corresponds with the first section of Unit 4A, which deals with factoring strategies that you have learned in your Algebra 1 course. So this video will talk about how to do 3 different strategies: how to factor out a GCF, how to factor using the difference of squares strategy, and how to factor a trinomial when the front term is simply an x squared with no number in front of it. You'll also look at how to factor completely, which just involves you knowing all these factoring strategies to be able to pick and choose the correct ones to use. So first here, we're going to look at how to factor out a GCF, or a greatest common factor, as it is called. Factoring out a GCF simply means we are looking for the greatest term to divide out of all terms within an expression. So if I look at the first example here at 4x squared minus 12x, we are looking for the biggest thing that'll divide out of both terms. So numbers-wise, I'll be able to divide a 4 out of both terms. I can also divide an x out of both terms. We show the GCF of 4x out front, and in parentheses, we're going to show what's left over by dividing that 4x out of both terms. So we start with 4x squared divided by 4x. The 4's cancel. X squared divided by x leaves you with an x. Then we look at the negative 12x divided by 4x. Negative 12 divided by 4 is negative 3. X divided by x cancels, and that ends up leaving you with a final answer of 4x times x minus 3. GCF can be used for 2 terms, 3 terms, 4 terms, 100 terms. Doesn't really matter. You're always looking for what is in common with all the terms within the expression. So if I look at the second one here, 10x cubed plus 25x squared minus 20x. First thing I'm going to look for is the biggest number I can divide out of all 3 terms. So in this case, the biggest number I can take out is a 5. Variable-wise, I can take an x out of all 3 terms, and then I'll open up a set of parentheses. From here, we're going to divide away that 5x. So we'll start with 10x cubed divided by 5x. 10 divided by 5 is 2. X cubed divided by x is x squared. 25x squared divided by 5x. 25 divided by 5 is 5. X squared divided by x is x. And then last but not least, negative 20x divided by 5x. Negative 20 divided by 5 is negative 4. X divided by x cancels, so we close it off. And that is finished and factored. So that is how you factor by using the GCF strategy. Now we'll take a look here at how to factor using difference of squares. So difference of squares you can use with 2 terms. You'll notice the structure of it as noted here off to the side. In order to use difference of squares, both terms must be subtracted. That's the first thing. If they're not subtracted, difference of squares does not apply, hence the word difference. The second thing that must occur is that both terms being subtracted must be perfect squares, which means they'll square root apart into nice values that you can evenly split amongst your factors. So if I have 2 perfect squares being subtracted, you'll see how they split apart and how they'll factor apart into 2 different factoring expressions. They look pretty much the same, the difference being the signs that are inside holding the A and the B term together. So let's take a look here at this first example. Here we have x squared minus 289. So first thing, we see subtraction. Now the second thing is, are they square rootable terms? Well, first and foremost, x squared, the square root of that would be x. Now we look at 289. We're going to take the square root of 289. It comes out perfectly to 17. So that is a perfect square. One gets a plus, one gets a minus. And the way that we factor it apart is x plus 17 times x minus 17. We can apply difference of squares even if there are more terms, we see more coefficients, more variables. It's still the same concept. They must be subtracted, and all the terms, both terms I should say, are perfectly square rootable. So we see subtraction in the second example. Now let's look at each term. 36x squared. Take the square root of that. Square root of 36 is 6. X squared, square root of that would be x. So our first term in each expression, in each factor, would be 6x. Now we look at the 49y squared. Square root of 49 is 7. Square root of y squared is y. Each would have a 7y, one being added, one being subtracted. Difference of squares does apply, even though there are more numbers and there are more variables. They are both perfectly square rootable. Therefore, it can break apart using the difference of squares strategy. The last of the review factoring skills is the ability to factor a trinomial. Now, you'll see in the future lesson that there are going to be other ways that you can factor trinomials apart, especially when you have a coefficient that's not 1 in front of the x squared term. But when you have a trinomial that simply starts with x squared rather than 2x squared, 4x squared, 5x squared, etc., we can simplify the process a little bit by knowing two things. You have a coefficient with the regular x term, and you have the constant value c. What your main goal is to figure out, in order to factor this apart, you want to figure out the two numbers that multiply to that c value and add to the b value. Think of what will multiply first to the c value, because there's only so many things that will multiply to certain numbers. Take those combinations, then you want to guess and check and figure out which ones of those will add together to make the number that you need. Once you figure out that combination of two numbers, then you can write your factors out. So, let's start with x squared plus 14x plus 45. So, my goal is to figure out the two numbers that multiply to 45, but then those same two numbers must also add to 14. The two numbers that will do that are 5 and 9. So my two factors will be x plus 5 and x plus 9. 5 times 9 is 45. 5 plus 9 is 14. That checks out, and I have my factored answer, x plus 5, x plus 9. In our second example, same idea. Our c value is the negative 36. Our b value is the 9. My goal is to figure out what multiplies to negative 36 and adds to 9. The two numbers that will do that are a positive 12 and a negative 3. 12 times negative 3 is negative 36. 12 plus negative 3 is positive 9. So my factored example is x plus 12 times x minus 3. When you have negatives in your trinomials, you do want to pay very close attention, as the signs will make a big difference. You do want to make sure that you apply the correct sign to the correct number. It's a little bit easier in the first example when everything's positive, because both your signs will be positive in your factors. You don't have to think about it as much. When you see negatives, you do need to pay very close attention as to how the negative sign will affect the one or both numbers that you could possibly need to figure out the correct combination. But again, that's how you factor a trinomial. Again, you're going to learn in a future lesson when we see a 2, a 5, a 7, when there's something out in front of the x squared that isn't that invisible 1. There's another way that we're going to work on how to figure out how to factor these apart. But for this, it's basically guess and check. What multiplies to c and adds to b. Finally, to wrap this up, we're going to take a look at what's called factoring completely. This isn't a specific strategy, but when you are just generally asked to go factor, or you see the statement go factor completely, this means you need to figure out any and all strategies that you could possibly use to break the expression down. Now, as a hint, anytime you are asked to factor, the first thing you should always look for is a GCF. From there, you can use your other factoring strategies that you have learned and that you will be learning in future lessons. So, if we take a look at the first example here, 3x cubed minus 15x squared minus 42x. First thing I want to do is check and see, does it have a GCF? The answer to that is yes. We can take a 3x out of all three terms and then show what's left over. So if I do that, I'd have an x squared minus a 5x minus a 14. So now that I've taken the GCF out, next thing I want to do is look in the parentheses and see, can I factor this further? Now, some cases, when it says factoring completely, you can only do one factoring strategy. Some cases, you may be able to do multiple factoring strategies. It just depends on what terms you have. So, if I look in the parentheses at x squared minus 5x minus 14, I want to see, can this break down using our trinomial strategy? And in fact, it can. So what I'm going to do is I'm going to pull down the 3x. Even though that's been factored out, it's still part of our problem, so we carry it down. We can break the trinomial that's in parentheses apart using negative 7 and positive 2. Negative 7 times 2 gets me negative 14. Negative 7 plus 2 gets me negative 5. So we could break down the trinomial that's in the parentheses into x minus 7 and x plus 2. We carry down the 3x, and that is as factored as that's going to get. Typically, in a factoring problem, if you get the problem to nothing but regular x's, so no x squareds, no quadratic terms, when you get it down to regular x's, there's a good chance you're probably finished with it. Some problems that have an x squared or an x cubed or something even higher than that power-wise, just because there is an x squared or something higher does not mean it necessarily breaks apart. So again, you do have to check your strategies to see if they work at all. You'll see that here in this final example. So in the last example with 12x cubed minus 72x, again, first thing to check for always and forever with factoring, is there a GCF? Once again, we have a GCF. Wrong buttons there. Let's try that again. We're going to go ahead and take out a 12x. So if I take out a 12x, I'm left with x squared minus 6. So we took out a GCF. Now we look in the parentheses and say, okay, we have two terms. Well, the only strategy for two terms that we know of is difference of squares. So first thing we got to check for is it a difference? Yes, we see subtraction. The second thing we got to check for is, do we have two terms that are perfectly square rootable? The answer to that question is no. X squared would square root into x and x. That's fine. You cannot take the square root of 6 and get a nice answer. That does not factor apart. Sure, you could square root it and get a decimal, and we could try to round it off. That is not the correct way to do it. Both terms have to be perfect squares. 6 is not a perfect square. Therefore, even though we're trying to factor completely, it only took one strategy. We took out the GCF, and that's all we could do. Like I said, some problems that will happen where you can only do one thing, and that's it. Some problems, like you see with that first example in part number 4 here, you can do two strategies, maybe even more. Just depends on what terms you have. So this is a review again of your basic factoring strategies, finding a GCF, difference of squares, and factoring trinomials. And then we finish it off here with how we can see maybe more than one strategy being used at the same time.